In this video, video 7 of Module 5, we're going to talk about change of variable in summations. This is something you've probably seen in calculus, and the idea is similar. When we go to apply the rules of summations, sometimes the bounds just don't work. So here we start at different bounds. This one we're starting at 1, and this one we're starting at 0. Here we're going to n, and this one we're going to n minus 1. The bounds don't work. And it's not the case, like in the last video, where we can just pull one element off and have everything line up. We're going to have to do a little bit more work. So that's what we're going to talk about in this video. We will come back to this problem, but at the moment, I'm going to start with something a little simpler. So I want you to notice that the sum of k equals 1 to 5, k squared, is equal to the sum of I equals 1 to 5 of I squared, right? The variable we use doesn't really matter. We can use any variable. I could use k, I could use I could use j, I could use anything. And more interestingly, notice that this is equal to j equals 2 to 6 of j minus 1 squared. Let's see how that works. Well, I'm going to write this first one out, and we're going to get k squared is, starting at 1, is going to be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, right? That is this summation right here. Now I'm going to write out this summation. We're going to have j start at 2. J minus 1 is 2 minus 1, which is 1, so that's 1 squared. Actually, how about if I do it like this? 2 minus 1 squared plus 3 minus 1 squared plus 4 minus 1 squared. I'm going to skip ahead to the 6 minus 1 squared. And now if I simplify these, 2 minus 1 is 1 squared. 3 minus 1 is 2 squared. Plus 3 squared plus 4 squared plus 5 squared. And look, these two are the same. So what we've done is we've shifted our bound, our lower bound up by 1 and our upper bound up by 1. And then inside our equation itself, we subtracted 1 to balance it out. So here this went plus 1, this went plus 1, and here we went minus 1 to balance everything out. Right, so what we have is we have 3 equivalent ways of writing this summation out. And similarly, let's see if I can clean this up a little bit. Similarly, I could write this in other ways. Right? Instead of going up 1 like we did here, we can go down 1. And if we go down 1 in both the bounds, we're going to have to go up 1. So these both went down 1, down 1. We're going to need to go up 1 in here to counteract. And again, I encourage you to expand this to convince yourself that it's the same as the others, but I'm going to let you do that on your own. The important takeaway here is that there are many ways of writing the same summation, right? We can adjust the variables. In this case, we've changed it from k equals 1 to j equals 2. We can adjust the variables, change the variables, to put this summation in the form that we're interested in. Right? This is very similar to use substitution in calculus. In this case, for example, I'm going to let j be my new variable and have it equal k plus 1. Okay, well, another way of writing that is I can write that in terms of k. What's k equal? Well, if I subtract 1 from both sides, I'm going to get k equals j minus 1. So these two equations mean the same thing, and they're equivalent. But sometimes one might be more useful to look at than the other. So the way we're going to do this, let me write these up here. Let j equal k plus 1, which means that k equals j minus 1. I'm going to do, first I'm going to look at the bounds. So step 1, calculate the bounds. So the lower bound, we have k equals 0, and we know that j equals k plus 1, right? That's up here in our change of variable. So if I plug in a 0 for k, I'm going to get this as 0 plus 1 equals 1. So I now know that my lower bound is going to be j equals 1. And so we can do this as we do the bounds. So now we've got j equals 1. Now let's do our upper bound. On our original summation, we have that k goes to 6. And again, we know that j equals k plus 1, so I'm going to substitute a 6 in for that k. 6 plus 1 gives me 7, which means my upper bound is j equals 7. And we can do a check right now. We can check, well, the k, we went from 0 to 1, so here we went from 6 to 7. So we went up on both of those. Now remember what we said before, if we go up on both bounds, we're going to go down on the guts of the problem. So here is where we're going to make use of the second part of our equation, right? This is why I calculated what k equals, is I can now substitute that in for this k. Now you might be saying to yourself, well, obviously, we have k plus 1 here. We can just replace that with the j. Well, yes, in this example that works, but not every example is going to be so straightforward. So what I'm going to do is I'm going to actually, just replace the k. So we're going to have 1 over k becomes j minus 1 plus 1, which simplifies out to 1 over j. And if you just see that, you can go straight there. But what I don't want is, in a more complicated problem, I want you to know how to deal with it. And the way I deal with it is we take our transformation. That's this. This is our transformation. And I'm going to rewrite it in terms of the other variable, so that I have an equation for each variable, j and k, and I can always substitute one for the other based on that substitution, based on that transformation. Oh, okay, so let's take another look at this problem that we started with. right? So this is the one at the very beginning of this video. I was motivating that this problem is difficult because we cannot just directly pull a term off to get the bounds to line up, right? We could technically pull a term off of the second one and then pull a term off of the first one, and we would get something that lined up, but that's a lot of work. Instead, what we're going to do is we're going to do a change of variable, which is going to work especially well if we have the same number of elements in each summation. So you can pause this video and try this on your own. But what I was saying a moment ago was that a change of variable is going to work especially well if we have the same number of elements in each sum, right? So if I expanded each sum, am I going to have the same number of elements? Well, here in this one, I'm going to have n minus 1 terms because I just subtract the upper bound minus the lower bound. And in this summation, we're also going to have n minus 1 terms. Again, subtract the top upper bound from the subtract the lower bound from the upper bound. So both of these sums have the same number of elements. We just need to do a change of variable to demonstrate that. So what I'm going to do is I'm going to keep my bounds in terms of k from 1 to n, which means I need to do a change of variable on the second sum. And we want to now here's a tricky part. How do I know what I'm doing here? What variable to let to equal what? Well, I'm trying to get to where k is equal to 1. So I'm going to be using k. And we started with j. And if I want k to equal 1, that means I want k to equal 1 plus j. Or k is going to be j plus 1. Right? And another way of writing that, I'm just going to keep this in red, is I can rearrange this and solve for j, and j is going to be k minus 1. So now I have my two equations or transforms. And what I'm going to do is I'm going to start with the bounds. So let's do the lower bound. So the lower bound of my equation is going to be j equals 0. But I want to substitute that into this equation here so that I get k is equal to 0 plus 1 equals 1. So in other words, k equals 1. And let's do the same thing. Here we can write this out. This is k equals 1. Let's do our upper bound. Well, in our original summation here, we have, whoops, there was a little computer glitch there. Let's keep going. So this upper bound, we have in our original sum, we have that the upper bound j is equal to n minus 1. And I can plug that into this equation right here and get that k equals n minus 1 plus 1, which is just n. So my upper bound is k equals n. So this was step 1 to do the bounds. Step 2 is going to be to fill in the body of the sum. Right? So in our original sum right here, we have our body is j squared. Well, I am going to use this equation right here to let me substitute for j. So I know that j is equal to k minus 1, so j squared is going to be k minus 1 squared. So we can put that back in here. It's k minus 1 squared. And we can do a quick check. Here we went in the lower bound, we added 1 to get to our lower bound there. In our upper bound, we added 1 to get to our upper bound there. So to balance things out, our body should subtract 1, which is exactly what we do. Okay, so now we have this rewritten summation with a change of variable that we can use to plug back into our original problem to solve it. All right, this is still what we're trying to solve up here. So we've only done the first step. We've changed the variable in one of the sums so that now they should match. So I'm going to go to the next page and I'm going to rewrite our equations using this new sum. So I'm going to rewrite what we had here, the original problem. And I'm going to substitute in for the second term here. So we had the sum from k equals 1 to n of k minus 1 squared. Okay, this is by substitution. Now we can make use of that first property of summations, where as long as the bounds are the same, we can combine them. Okay, and we're done. We could simplify this further if we wanted and expand that, but I'm not sure that that's actually simplifying it. That's just expanding. So I'm going to stop here. So the result of adding these two sums together is going to be this.